Alright guys, so we're going to start reviewing for your first test of the third quarter. So it's a fresh start. For number 1, determine the remainder when f of x is divided by x minus 4. So you can go ahead and do long division if you want to, but a quicker way for you to do this is to say, okay, well, the remainder theorem says that the remainder is the y value, if I were to set what I'm dividing by equal to 0, and then solve it. So I'm looking for the y value when x is 4. So I would do f of 4, so I would do 4 times 4 to the third plus 3 times 4 minus 2. You can type that right into the calculator. That gives you 266. So the remainder is 266, which it doesn't ask you this, but that also means that x minus 4 is not a factor of f of x. For number 2, positive exponents only. So everything in the numerator is being raised to the negative second power. So this is 3 to the negative second, k to the negative 10, because power to power you multiply, divided by 5, h to the negative fifth, k to the negative fifth. So then you're going to circle your negative exponents. Again, you don't have to do this, but this is how I showed you how to do it in class to make it a little bit easier. Circle negative exponents. So the only thing that I have right now is a 5 in the denominator. 3 to the negative second becomes 3 to the positive second in the bottom. K to the negative 10th becomes k to the positive 10th in the bottom. H to the negative 5th moves up to be h to the positive 5th. And then k to the negative 5th moves up to become positive as well. So now if you actually do, in the denominator, 5 times 3 squared. 3 squared is 9 times 5 gives you 45. You have only one h. So that stays the same. And then your k's, k to the 5th divided by k to the 10th. 10 minus 5 is 5, and that goes to the bottom because the 10 is bigger. So this is your final answer to number 2. Number 3, factor completely. So whenever you have 4 terms, you're going to try to just split it down the middle and see if factor by grouping works. So on the left side, you could take out x cubed. You're left with x plus 2y. On the right side, there's a GCF of 125, so that comes out, and you're left with x plus 2y. So your parentheses match is how you know that you're correct. So this is x plus 2y times x cubed plus 125. Now, because this says factor completely, though, you have to make sure that there's nothing else that you can do. So you can't do anything else with x plus 2y. However, x cubed plus 125, that's the sum of 2 cubes. So you can do sum or difference of 2 cubes. So you are going to have a small set of parentheses and then a big set. So you have a binomial and a trinomial. You take the cube root of each one. The cube root of x cubed is x. The cubed root of 125 is 5. We will worry about the signs after. So if you remember, this was a, b, a squared, ab, and b squared. You don't need to put this on the bottom. It's really not part of your answer. But if a is x, then a squared is x squared. A times b would be 5x, and b squared would be 25. And then for the signs, you use SOAP. Same, opposite, always positive. So this was plus, so then this is going to be plus. So same, opposite, always positive. For numbers 4 through 6, I'm giving you different types of equations to solve. For number 4, this is a square root. So you need to isolate the square root. So you have the square root of x plus 2 equals, you subtract the 2x and you get 2x plus 3. Now you square both sides. You get, this cancels out, so you get x plus 2 equals. Make sure you double distribute the right side, and you get 4x squared plus 12x plus 9. Set it equal to 0. 4x squared plus 11x plus 7. You're going to do master product. When you're done with master product, it should turn into 4x plus 7 times x plus 1, which gives me x equals negative 7/4, and x equals negative 1. You have to plug these back in and check them. Negative 7/4 does not work, so that answer gets rejected. However, negative 1 does work. For number 5, your variable x is up in the exponent, so you're going to need to use logs. Not only do you use logs, but because the base of the exponent is e, you're going to use the natural log. So first you're going to add over the 4. So you get equals 64. Now you also have to divide by 5. So we have e raised to the 2x plus 1 is equal to 64 divided by 5 is 12.8. So now you have the base and the exponent isolated. You're gonna take the log of both sides, the natural log of both sides. That way you can pull the exponent down out front. So now this is 2x plus 1 times the ln of e is equal to the ln of 12.8. The ln of e is really just 1, so you don't have to divide it over. If you were doing the log, then you would, okay? You could still do this correctly without taking the natural log. So it's not really that it matters, it's just what's preferred. So this is really 2x plus 1 is equal to the ln of 12.8. So remember, you're not rounding until your final answer. So we have 2x plus 1, 2x is equal to, you would subtract 1. So do the ln of 12.8, close the parenthesis, and then divide, and then subtract 1. So ln 12.8 minus 1. You're going to write 5 decimals down at least. You get 1.54944, and then you divide by 2. And now you're going to get x equals now. So now you can round to the nearest 1,000. So you get 0.775. And then for number 6, the log base 7 of x squared minus 1 minus log base 7 of 2x plus 2 equals 0. Condense the logarithm. So this is being divided. So it's going to be log base 7 of x squared minus 1 over 2x plus 2 equals 0. So now you're going to rewrite it as 7 to the 0 power equals x squared minus 1 over 2x plus 2. 7 to the 0 is 1 equals x squared minus 1 over 2x plus 2, and then you can cross multiply. Remember, 1 is really 1 over 1. So you get x squared equals, distribute the 1, equals 2x plus 2. X squared minus 1, sorry. X squared minus 1 equals 2x plus 2. Set it equal to 0. It is x squared minus 2x minus 3 equals 0. Then you would do master product. When you finished with master product, it should be x minus 3 times x plus 1 equals 0, giving you x is equal to 3 and x is equal to -1. You plug your answer choices back in, and -1 does not work. For number 7, you should type this into your calculator. That way you get an answer and you can tell right away if something goes wrong. So when you type this in, you press the matrix. So you would do second matrix, you go to edit, you input everything in, and then you leave the screen. Then you would do second matrix, go over to math, and it's called RREF. So your answer to this question should be 0, 0, -6, -8. So as you're going through, if you see that something does not work out, that something doesn't match this, then you probably have a mistake somewhere in that area of your work. So you're going to do elimination on equation 1 and 2, then elimination on equation 1 and 3, and then those give you equations A and B, and you do elimination again. So it's a lot of elimination. So we have -4x, do this over here, -4x minus 7y minus 4z plus 4z equals 10. Then you have x plus 4y minus 4z equals 8. Now this elimination is nice because your z's are already going to eliminate. So I'm going to get rid of these. -4x and x give me -3x. And you have minus 3y equals 18. Remember, you're adding down for this. Adding down. So this is now equation A. Now you're going to do the same thing on equation 1 and equation 3. So I have -4x minus 7y plus 4z equals 10. And then 7x plus y minus z equals 2. So here because I eliminated the z's the first time around, I have to eliminate z's again. So I'm going to take my second equation and multiply it by 4. That way I get 4z and -4z. So now this is -4x. The top part stays the same, minus 7y plus 4z equals 10. And then the bottom equation is the one that you multiplied by 4. So that one's going to turn into 28x plus 4y minus 4z equals 8. So now you add down. This is going to cancel. You get 24x minus 3y is equal to 18. So this is equation B. Okay, so now I'm going to take my two equations, A and B. So I have negative 3x minus 3y equals 18 for A, and for B it's 24x minus 3y equals 18. And what I'm going to do now is I'm going to do elimination one more time. So I'm going to multiply this top equation by negative 1. That way now it's 3x plus 3y equals negative 18. And then I'm going to add down. So 24x and 3x is 27x. Negative 3y plus 3y cancels out, and 18 minus 18 is 0, which gives me x is equal to 0. Once you know 1, it's then you're just doing a substitution to get all of the rest of them. So x is equal to 0, so this works because x equals 0 in my answer that I got before I even started the question. So now I have negative 3 times 0 minus 3 times y equals 18. I'm getting this from equation A. So 0 minus 3y equals 18. That's going to give me y is equal to negative 6, which y equals negative 6 is what I have up here. So now I use x and y, and I plug it into one of my originals. So I have x plus 4y, so x, I'm going to plug it into equation 2, plus 4y minus 4z equals 8. This is going to be negative 24 minus 4z equals 8. Negative 4z is equal to 32, and you get z is equal to negative 8, which works out as well. So my final answer, you have to write as a point, 0, negative 6, negative 8. Final answer. Okay, for numbers 8 and 9, state the following key features. So the domain, the range, the asymptotes, and the intercepts. Round any decimals to the nearest hundredth. So for number 8 is an exponential function. Exponential functions, remember, they look something like this. That's typical. Okay, and especially because this is an example of exponential growth. So the domain for number 8 is all real numbers. It keeps going all the way to the left, all the way to the right. Your range for number 8, well, actually, you know what? I'm going to find the asymptote first. Exponential functions have horizontal asymptotes. Those horizontal asymptotes get moved during vertical shifts. So number 8, there's a vertical shift down 3. So the asymptote y equals 0 is now y equals negative 3. You can see that in your calculator too. So because this is equal to negative 3, your asymptote, your range is that y has to be greater than negative 3. If you looked at the graph of this graph looks like this. So y is greater than negative 3. And then your intercepts, you have x-intercepts and y-intercepts. It doesn't say algebraically to find them. So the y-intercept is 0, negative 2. That's where x equals 0. That's a little bit easier to see. The x-intercept, you go into your calculator, type the function in, you press second, trace, number 2 is 0, so that's x-intercepts. And it says round any decimals to the nearest hundredth. You get 1.58, 0. Okay, that's, again, second trace, and it helps you, and you can find all the key features that way. For the next one, number 9, log base 5 of x minus 2. So if you look at this one in your calculator, this one looks like this. So it doesn't show it going down as much. It doesn't show the asymptote that well. But remember, a log function has a vertical asymptote, which gets shifted when it's a horizontal shift happening. So this one's a shift to the left too. So this one has a vertical asymptote at x equals 2. Your domain then is what's different because x cannot be equal to 2. X is also greater than 2. Your range, however, is all real numbers. And then for this one, the intercepts, there is no y-intercept for this function because it does not, your x value can never be equal to 0, meaning no y-intercepts. However, your x-intercept, if you look at your calculator, 3, 0. Okay? Again, you can do second trace number 2 to find the x-intercept if you want, or you can even look at the table for this one. Number 10, algebraically determine all intercepts. So algebraically, we have x-intercepts and y-intercepts. X-intercepts are where y equals 0. So I do 0 equals log base 3 of x plus 9. So to solve this, I have to get rid of the log function and put an exponential in there. So this is really 3 to the 0 power equals x plus 9. 3 to the 0 is 1 equals x plus 9, so I get x is equal to negative 8. But I'm going to write it as a coordinate because intercepts have to be coordinates. So it's negative 8 comma 0. Y-intercept is where x equals 0. So y equals log base 3 of 0 plus 9. 0 plus 9 is just 9. So log base 3 of 9. You should be able to do this in your head. This is really saying 3 to what power gives you the 9. So you will get y equals 2 even if you type it in your calculator. So then this y-intercept is 0 comma 2. So these are your two intercepts. For number 11, in a lab experiment, so from here down we have all the word problems. So you need to know those 5 equations. For number 11, we have the population of bacteria is growing. So that's an exponential growth, right? So it's starting off at 7,400. So that goes in for P. And it's growing 20% per day. So 1.20, and T is in days. So this is now A equals 7,400. 1.2 raised to the t power. The problem is that the question says to write a function to represent the population of bacteria where the hourly rate of change can be seen. Here I can see the daily rate of change because t is in days. So I have to go from days into hours. So to go from days to hours, you would take the number of days and multiply that number by 24. You can't just do that, though. You have to do something that balances out the equation. So if you're going to change the exponent to be 24, you have to raise what's inside to be 1 over 24. So now you have this, 7,400 times this number raised to the 24t. The question also says to round any decimals to the nearest thousandth, I believe, right? Thousands? Yeah. So then if you type this into your calculator, your final answer is 7,400, 1.008 raised to the 24t. Number 12, we have radioactive substance, and it's talking about asking for the half-life. So half-life formula, A equals P times 1/2 raised to the T divided by H. We are solving for the half-life, so we have to plug something in for everything else. 16 grams were stored, so P is going to be 16. After 10 years, only 11 grams were left. So A is 11, and T is going to be 10. Then you take the log of both sides. We have the log 0.6875 equals 10 over h, log of 0.5. You divide by the log of 0.5. Again, 5 decimals at least until you get to your final answer. And you get 0.54046 equals 10 over h. At this moment is where I want you to cross multiply. The amount of people that are going to get this question wrong because they don't just cross multiply, it's going to be too many. So you get 10 is equal to 0.54046h. You divide by 0.54046. And you really divide by the whole decimal that's still in your calculator. And you get, we are rounding to the nearest, what do we round to? The nearest tenth of a year, so you get 18.5 years for the half-life. Question number 13 starts talking about compound interest. So again, this is another formula that you need to know. The compound interest formula is A equals P times 1 plus R over N raised to the NT power. The question is how many years it would take for there to be 24,500 in the account. So how many years, that's your variable T. So A, we want to be 24,500 equals, P is going to be 15,000, that's how much it was to start. Then you have 1 plus R, you move the decimal over twice, so it's 0.045 divided by N, which is 2 because it says semi-annually, raised to the 2t. So again, your first step is always going to be to divide the 15,000. So this is this is 1.63 repeating, equals, if you actually want to type this piece into your calculator, you can. You get 1.0225 raised to the 2t. Then you take the log of both sides. 1.6 equals 2t log 1.0225. And then you divide by the log of 1.0225. And you would get 22.04986 equals 2t. Divide by 2, round it to the nearest thousandth, you get t is equal to 11.025 years. For number 14, Stephanie invests $550 compounded continuously. So whenever you see continuously, that's your APERT. How much money will be in the account in 6 years? That's your first question. So how much money will be in the account? That's A equals, you're starting off with $550. E, your rate is 1.5%, so 0.015 times T, we want it to be 6 in this case. And remember, it's money. So 2 decimal places, and you will get $601.80 for the first question. How long will it take to have 1625 in the account? So 1625 equals 550e to the 0.015t. Divide by 550, and you get 2.95454 equals e raised to that exponent. Take the ln of both sides. Ln of 2.95454 is equal to 0.015t ln e, which is going to cancel, and then you divide. You should get round to the nearest tenth, 197.0 years. Rounded correctly would be 0.0. Number 15, the value of a 30,000 car depreciates at a rate of 17% per year. How many years will it take for it to be half of its original price? So it was 30,000. We want it to turn into 15,000. This is regular exponential decay. So it's 1 minus 0.175 raised to the power of t. Divide by 30,000, you get 0.5 equals, this would be 0.825 t. Log both sides. T log 0.825. Divide by the log, and you will get t is equal to 3.60 years for number 15. And for number 16, during the years 2000, 2020, mosquito population is that function. A is population in thousands. T is time in years. State whether it's growth or decay. This is going to be growth. And it doesn't ask you to explain why, but it's growth because your base of 1.02 is bigger than 1. And then also find the rate of growth or decay. So you would take 1.02. Remember, this is in the spot where 1 plus r is because it's a growth, right? In your formula, it's A equals P times 1 plus r to the power of t. So 1 plus r is where the 1.02 is, so you can solve it that way. So when you subtract the 1, r, you get 0.02, which is, move the decimal over twice, 2%. So it's a 2% growth. to the nearest whole, predict the population of mosquitoes in the year 2014. So 2014, it's been 14 years since 2000. So you would do A equals, keep this equation, so 1600, 1.02 to the 14th power. Now, though, the problem is that A is the population in thousands, and we want rounded to the nearest whole. So when you plug this into your calculator, you get 2,111.16602. You take that number and you multiply it by 1,000, because your equation is in thousands. So you actually get 2,111.162 blah 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 thousand. So you multiply by 1,000 and round to the nearest whole, you get 2,111,166 mosquitoes as your answer. Okay? If you have any questions, let me know. Again, your test is going to be on Thursday this week. Have a good night.